Hello everyone. Today we're going to tackle problem number 4 in DeepML, which is calculate mean by row or column. As in the previous video, this video is geared towards absolute beginners, and so I'm going to explain a very long-winded way of trying to solve this problem, which can help you understand what's happening underneath the hood. But afterwards, I'm also going to give the more efficient solution, which is what you would do if you were trying to make production level code or trying to make something more sophisticated. The purpose of this video is to teach absolute beginners how to get started with this and get a better idea of what's going on. So feel free to skip around if you're familiar with some of the stuff we're covering here. And if you don't, then don't worry about it. I'll make sure that you get what's happening by the end of this video. So in this problem, we're given a matrix, which in Python is represented as a list of lists. And we're given a string as well, which can be either column or row. And depending on what it is, we're going to calculate the mean either by going row by row or going column by column. And just to give you just to visualize the example that we're given here. So we're given a matrix that's 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 3 rows by 3 columns. And depending on the mode, we're going to get a different result. So for example, if we're looking at a row, calculate the mean by rows, what we're going to do is we're going to sum all of the elements here, which is going to get 6. And then we're going to divide that by the number of columns that we have, which is 3. So 6 divided by 3, that's going to be 2. Similarly here, if we follow that same idea, we're going to get 5. And here we're going to get 8. But what happens if we look at all of these elements going down by columns or going up, whichever your preference is? Well, here we're going to get a 4 for the first column. We're going to get a 5 for the second column, and we're going to get a 6 for the third column. So as you can see, depending on whether you're looking at rows or columns, you're going to get different numbers. And that's because when you're looking at rows and columns within this matrix, you're looking at different elements. So it makes sense that the mean of those different elements is going to be different. Now that we understand a little bit about what it is that we're doing with the numbers, or rather, if you had a matrix and you were looking at it, how it is that you would operate with it, let's think a little bit about how we're going to translate that to code. Because as I just mentioned, this problem is somewhat easy to understand intuitively, but there's going to be certain nuances that have to do with programming, not only in Python. If you did this in other languages, you would run into similar problems that we have to be very aware of before we start coding. Before you ever touch the console and try to code, I suggest you take a step back and start thinking about what it is that could complicate your life when you're trying to solve this problem. So again, we're looking at a matrix, which is a list of lists, and we're looking at a string, which is mode. As we saw, let's go by perhaps the most egregious problem, which a lot of people may not consider when they're solving this problem, which is the mode. So the way in which you can calculate the means can be by row or by column. But what happens if the user says something else? Because it can pass any string, right? So what happens if it passes dog or cat? Well, there's no way to calculate the mean using the dog or cat criterion, at least that I'm aware of. So we're going to have to, as a reminder, we're going to keep track of making sure that the mode input is valid. And that means that if it is row, we're going to follow certain logic. If it is column, we're going to follow another logic. If this is anything else, we're just going to throw an error. We're going to say, hey, the mode has to be row or column. Whatever it is that you gave me doesn't fit that, so we're going to ignore it. So that's the first step. We have to keep in mind what makes a valid input. Afterwards, we have to think, well, how do you work with matrices on Python? And as I said, a matrix, you get use a NumPy array as we did previously, but let's start with the core. Let's start with a list of lists, which is the way Python works with this thing. Because the way Python represents these matrices is by having a list that inside has other lists. And one of the neat things about this is that if you look at the way it's constructed, it is by stacking rows. That is, every list that's inside of the bigger list, which is called matrix, corresponds to a row. And so what you're doing when you're building a matrix is you're adding rows inside of a row. So following that logic, let's say, for example, we wanted to add an extra row. Well, let's say we wanted to add an extra row. Well, we could do that by simply appending this. It would just stretch it out, and we could add an extra row like this. 10, 11, 12. And so that's very simple. Now the matrix could be 4 by 3 instead of 3 by 3. And that's super straightforward. But what happens if you want to add an extra column? That's not as straightforward. The reason is if you want to add an extra column, you have to manipulate the rows that already exist. You would have to extend this. So instead of every row having 3 elements, every row would have to have 4 elements or 5, depending on how much you want to add. Why am I taking this detour? Well, because keeping in mind how to access data, how to access data is a very important way, or rather, it's a very important consideration to keep in mind when you're trying to solve these problems. Now, how am I going to solve this? As I said at the beginning, I'm going to do it in a very non-efficient way, which is tailored towards beginners, and I'm going to use this formula. So if you're getting the mean by rows, we're just going to grab every single element from a row, we're going to add it, and we're going to divide it by the number of elements in each row. How much is the number of elements in each row? Well, that's equal to the number of columns, right? From what I just said about the description of the way matrices are built on Python, well, that would also work if you're doing it in a different language. And how are we going to get the mean by columns? It's kind of the same idea. We're going to look at each element within the column, we're going to sum it, and then we're going to divide it by the number of columns. Now, in the most efficient solution, the way that Python describes its matrices is going to play a little trick into what we do. What I mean by that is it's not going to be as straightforward as the rows, but in this first, what I call the naive solution, the code is going to be pretty much the same for one or the other. So let's jump into the first solution, figure out how this thing works. Okay, so we're here. Let's start writing the code. As I said, we're going to have two big considerations. Well, we're going to have to keep track of the base case where the mode is not valid. Then we're going to look at the logic for the rows, and then we're going to look at the logic for the columns. So there's many ways you can do this. This is my favorite. So if mode is not in a list that has row or column, that is, it's not one of those, then we're going to raise a value error. Now, we could also do a return, and that's fine. But the reason why I'm doing raising a value error is because that's more informative to someone who's debugging the code instead of having a return. Because if you return something, maybe the person will think that the code executed because you had a return. But if you raise a value error, then undoubtedly something went wrong. And the task is to figure out what's happening with that. Why did it went wrong? Okay, so if the mode is no row or column, if it's cat, dog, whatever, then we're going to just stop the word. What happens if it is a row? So no matter if we're calculating the means by row or columns, we're going to define certain variables. So first of all, it's always useful to store the number of rows that we have, which is length of matrix. Remember, because a matrix is a list of lists. The numbers of lists inside of that list of lists is the number of rows. And the columns is simply how many elements each row has. By convention, you just call len of matrix 0. That's because you will always guarantee, if you have a matrix, you're guaranteed that there's going to be at least one row. Okay, and the other thing is that means the return is going to be a list. So let's work it out from here. How do we know if we're going to calculate the mean by rows? Well, that's if we use what's called mode equals row. So in that case, how are we going to proceed? We're going to go row by row. We're going to do for our in range rows. That is for every different row. We're going to initialize a new variable that we're going to call mean. And then within that row, we're going to go through every single element that exists. That is, through every column that exists in the matrix. So for C in range columns. Now what we're going to do is we're going to add to this variable mean the value that's stored in matrix RC. And we're going to do that for every single column. That's exactly like in the example that I gave. You're going to go through this, add all of this up. Now, in order we have the sum of all of the elements in the row. What do we do to get the mean? Well, we simply divide that by the number of elements within that row. And how many elements does a row have? Well, that's equal to the number of columns. And with that, we get the mean per row, and we're going to add it to a return list, which is called means. And that's the logic. As I said, we're going row by row, grabbing each element, which are all of the elements in the columns. We sum them up, and then we divide them by the number of columns. And that's how we get our value. The logic for the columns is pretty similar. Because we did an if here, we can do an else here. So instead of going row by row in the outer loop, we're going to go column by column. And inside of each column, we're going to go row by row. And the rest of the code is pretty much the same. We're adding each element of the matrix to this variable that we're storing. But when we're trying to get the mean, instead of dividing by the columns, we're going to divide by the number of rows. And then we're going to add the mean to the list of means that we define over here, and that's going to be our result. So if we run this code, we're going to figure out that it works. Both these cases are accepted, and it works. Now, this solution is pretty good to understand what's happening underneath the hood, but it's not efficient at all. Doing for loops, double for loops in Python or pretty much any programming language is very costly in terms of time. It worked pretty fast because we have a small matrix, but if we had a bigger matrix, we can take advantage of and leverage some of the features that Python has in order to find a faster solution. And that's exactly what we're going to go do right now. Okay, so we're back. Now I'm going to show you a faster way. This is very similar to the solution that's on the website, but it's going to be edited a little bit just to follow kind of the process that I did before. So we're going to leverage some of the faster things that we can do. First of all, let's just take care of the base case. So if mode not in row or column, that is, if it's not one of those, then as in the other case, we're going to raise an error. Mode must be row or column. Okay, fantastic. Now let's think about what happens if the mode equals row. As I said before, lists in Python, matrices in Python are a list of lists. And so here, if we access each of the elements inside of the matrix, we are going to be looking at a list itself. So when you do an iteration, when you do something like this for row in matrix, like when you do a for loop, you're just telling Python, hey, grab every single row that's inside of matrix and start working with it. So we're going to leverage that, and we're going to leverage something that's called list comprehension in order to work. Now, what is a list comprehension? So a list comprehension is a way to create a list using just one line and multiple expressions. So for example, if you had something like this, 2 times I for I in range 2, well, what that's going to generate is a new list that's going to be 2 times 0 and 2 times 1, because those are the numbers in the range of 2. Remember that it starts from 0 and gets to the number right before the argument of this range function. So with this, we would generate a list that goes like this. So now that we know that matrices are built by making rows, by making lists of lists, and every single list is a row, how can we leverage that? Well, remember that the way in which we calculate the mean by each row is just by summing all of the elements inside of a row and then dividing that by all of the elements that are inside of that row. That is the number of columns. So we can do that with an expression like that in pseudocode. The good thing about Python is that pseudocode and the actual code are very similar. So we're going to create a list comprehension that is a fast way to generate a list, and we're going to leverage this expression. So I want to apply this expression for every single row that exists within the matrix. So if I do that, I'm going to generate a list where every element is going to be look at every single row, add all of the elements, and divide it by the number of elements that exist inside of this row. And that's the mean. So a faster way to get the row is by doing this. And look, this is going to save us like 13 lines of code, and it's going to be way, way faster. Using list comprehensions is a very fast thing within Python. So this is going to take care of the case of the rows. But what about the case of the columns? Could there be any problem? And let's think about it for a moment. As I said before, when you're working with matrices in Python, you're grabbing lists of lists. Let me make a smaller matrix just to get the point across. So it's very easy to access the rows, but how do we access the columns? It seems like we're doomed, right? It seems like we're doomed to do a double loop, because how else are you going to tell Python, hey, just look at the first element of all of the rows that exist, and then look at the second element of all of the rows that exist, and then look at the third element of all of the rows that exist. It seems that in order to do that, you would have to make an instruction that goes through every single row. And so you would have to be doomed to do a for loop, again, a double for loop. Let me tell you that Python has a very clever thing, which is called zip. And what this thing does is that it's going to be able to disentangle all of the rows and order the elements on a column basis instead of a row basis. Let me show you. Here I am looking at a Python console, and here's some code that I made. So here I defined a matrix, and let me just also run this little piece of pseudocode here for you to see. So the first print is going to be the means of every single row. What is this other thing that's going on down here? Why are there so many chain functions? Let's go step by step. First, we're printing it. We're generating a tuple. A tuple is kind of like a list. It has other properties, but for the sake of this video, like just think of it as another way to order information. And what we have inside here is this zip element. What zip does is that instead of grabbing everything by a row basis, it's going to grab all of the single elements of each row and stick them together in order, right? It's going to look at every single list, in this case, every single row, and it's going to grab all the elements in order and generate new elements. So it's going to look, hey, I'm going to go on every row. I'm going to grab the first element. I'm going to get 1, 4, 7. And then I'm going to move for every row. I'm grabbing the second element, 2, 5, 8, and then 3, 6, 9. And that's exactly what we want. That's exactly what we need. The way to order the matrix on a column basis instead of a per row level. So if I run this code, you can see that this thing is being ordered just on a column basis. 1, 4, 7, 2, 5, 8, 3, 6, 9, which is exactly what we want. So we can leverage the zip function in order to get the output that we want and condense all of the elements and do something similar to what we did with the rows. And just for completeness sakes, let me show you that the list comprehension that I described earlier works for the rows as well. Okay, so we're back here and we're going to do something very similar to what we did with the rows, but just for the columns. So how will we operate? Well, we would say, I want to sum all of the elements in the column. I want to divide it by the length of the column. And I want to iterate for all of the columns in matrix. No, that's not right? Because when you do it like this, you're operating on a row by row basis. We're going to use what we just learned, which is calling zip, and then this asterisk matrix. And with doing that, the Python compiler is going to zip the list. It's going to look at all of the elements in order in all of the lists. It's going to combine them, and that's going to give us the ordering in a column basis, which is exactly what we want. So if we run this code, it's going to take a little bit, but we get the same solution. Now, as I said at the beginning of this video, the first solution was just a way to show you what's happening underneath the hood and a way to think about the problem if you didn't have any tools, if you didn't have any knowledge of what you can do with Python. This other solution is more Python specific. It's way faster. These comprehensions are an amazing tool to have in your arsenal. And this is mostly what you would do when you're trying to to do something similar implementation within a production environment. Don't worry too much about knowing the nitty-gritty about zip. There's a lot of great resources for understanding the function. For now, just think about it in the context of matrices and think about it about how it can help you get all of the elements on a column by column basis. Well, this was the video. I hope that this helped. If you have any questions, be sure to leave it down in the comments section. Happy to help and happy coding.